Work it, make it, do it, make sense.
The case for Kotlin and Ceylon, so you're obviously in the right place because that sign was up initially. I had thought actually of calling it Java is stagnant. Thankfully we have Kotlin and Ceylon. Actually stagnant was a pleasant word. I thought of something else, but it wasn't printable. But no, I thought let's go with the case for Kotlin and Ceylon. Sounds sort of vaguely legal, as though we're in a courtroom type thing. So let's present some evidence. Well, first I guess we have to introduce the personae involved in this. And you will notice that I am very X. Yeah, okay. So I'm not yet an X person. I'm still being nailed to the chair to sit upright. Not very many people into Monty Python. Okay, right, well, that's a whole load of jokes have gone. Yes, I'm retired, therefore I have no agenda. I'm not trying to push my consultancy or a particular product. Also, this is pure opinion in some sense. I'm giving evidence. And so I don't care who I offend. The defence advocate, as you can see, is completely and totally missing. So if you feel I'm being over the top, do come in and say, no, that's wrong, or something of that sort. No rotten tomatoes, no swear words. But you are the jury. I'm here to try and convince you at least to go and have a look. That's really the purpose of this. So it's to convince you that there might be something for you to go and have a look at. So that's my goal. First, though, we need a bit of a prologue. Not everything. There is a huge difference between Java, Kotlin, and Ceylon. And I'm just skimming the surface. We've only got like 47.5 minutes. So it needs to be a surface coverage. I hope I've picked out a few points that really got me interested in these language differences. So let us begin the case for the offence. Java is a tediously old programming language. It's been around since, I don't know, what, 1991? Okay, it was called Oak then. It wasn't even called Java then. Java really 1994, 1995. Therefore, it's 22 years old. It's allowed to drink beer. Clearly, though, it's not old, not in the sense that I'm old, mostly because I predate Fortran, which most of you probably don't. So old here I'm using as a relative term in terms of the history of programming languages over the last 20 years. But it is very definitely steeped into the imperative and object-oriented histories. And I'm kind of assuming that you folks know a bit of Java and the terms imperative and object-oriented pull on your world knowledge. So I have no real intention of trying to explain those terms. Java, as we know, how many years between releases? Yeah, a few. It used to be like Fortran and C++. You got a new one every 10 years. At least they've sped that up a little bit, though one hears rumours that Java 9 won't be appearing in July. But I think my most important point that I'm going to present is that Java is not keeping up with the progress in programming language design and what software development actually is. Having said that, though, the Java platform, the JVM itself, I want to separate from Java the language. Okay, JVM was invented to enable Java. But I think, as we've got here, it's not just Java. We've got Scala. We've got the Kotlin and Ceylon I'm going to talk about. Frege. Anyone interested in that? I'm doing a 2-hour session tomorrow morning that will involve Frege. I don't think many people actually use Phantom, nor Gosu, nor Golo. Anybody using Jython is doing it wrong. Groovy appears here and here. Anybody spotted what the top line is versus what the bottom line is? I can hear people sort of trying to mutter the right words. It's all about static compilation versus dynamic compilation, as it were. The lower line is the dynamic languages, where what they really mean is compile time type checking. And the top line is compile time type checking. You do it all. And Groovy appears in both. And I'm just going to leave that hanging. Okay, so we've got to have a little bit of philosophy, because you just have to do philosophy. And so we want to ask the question, is change good? So a bit of audience participation, because. How many people think change is a good idea? Well, quite a lot of you. How many people think change is a bad idea? Yeah, I'm kind of split down the middle here, really. But it has to be said, not many people thought change was a bad idea. Let's unpack that a little bit, though. Is change good? Well, I'm going to claim that change threatens backward compatibility. And as we know, in Java language development, and even more in JVM development, backward compatibility is seen as a sacrosanct thing. If in Java 9 you cannot compile and run 1995 Java 1.0, something is wrong, apparently. On the other side of the fence, of course, change, new knowledge, new techniques, new tools, new ways of doing things. How do we make software development easier and nicer for ourselves? And so we've got yes and no. I'm going to actually challenge this backward compatibility thing. Basically, I think it's a crock of effluent. Where would we be if we didn't go with some change? Well, how many people actually like coding in machine code? Yeah, not many. I used to know the PDP-8 and PDP-11 bootstrap loaders, and you just sort of toggle them in, and that was it. That was the end of my machine code like. Assembly language, yeah, I guess if you're doing really, really low-level things like in operating systems, trying to do context switching really quick, you don't do it in C, because C is just too damn slow. You do it in assembly language. But out of that, people said, we've got to develop, we've got to improve our languages, and we ended up with, or on this side, Fortran. And no, wrong. Fortran. Fortran is not the same as Fortran. Fortran 1, 1957, I think. Fortran, 1995. They're different languages. Well, no, they're not different languages, but no, forget that one. Up here, of course, we've got the one true language, the last language, 1954, I think. So, the world ended in 1954, really. Yeah, okay. But change, where have we ended up? Well, Java comes along in here. Yeah, it's not procedural. I suppose you've got things like Pascal. You've got C++ in here, C in here, I guess. Though actually C is really down here. It's an assembly language that's portable. whatever. But where do you go from object-oriented, given that it's wrong? Everyone went, when late 80s, early 90s, everyone said, object-oriented is the only way to do things. You have to be object-oriented. And nobody knew what it was. Well, some people did, and they charged like £100 an hour trying to tell you about it. And of course, during the same time, we got Miranda, KCL, KRC, Hope, languages like that led to Haskell. And Haskell became, if you like, the poster child of the functional languages, even though Lisp is really the poster child of functional languages. And then, which language filled that gap? People are afraid to speak out, but yes, absolutely. I heard the lips move. Scala is trying to be a step on from Java by changing things, by progressing our understanding. Instead of just being object-oriented, we're going to say, well, those folk over there have got some good ideas. Haskell was doing some good. And so we've got actually a move. No, pause. I went too far. I got carried away. Apologies. Backtrack a little bit. Remember I said I will use the word. Backward compatibility is evil. Because it's the enemy of progress. If Java was all there was, and we were still stuck with Java 1, we wouldn't actually have Java 9. Well, we're probably not going to get Java 9 yet, but we wouldn't have Java 8. And Java 8 is a significant improvement over Java 1. But we had to have change in order to get there. So if everything was all about backward compatibility, then we wouldn't do anything. We'd just have this, we'd be back in machine code, to be honest, because we wouldn't be allowed to progress any further because of backward compatibility. Just as a footnote on that, if any of you know Fortran or COBOL, you can get a really good income from either NASA or the British government, both of whom have an awful lot of Fortran code, and all the Fortran people who know Fortran have retired. Either that or they're already dead. And so there's a desperate urgency for Fortran programmers. Java, never mind. Let me be honest, backward compatibility is all about companies refusing to move stuff on. Oh, we've compiled it. It runs. Don't change it. Leave it there forevermore. Who are the worst offenders of this? CPD people, computational fluid dynamics, weather people. They've still got 1967 Fortran codes that they require to run. And so the Fortran compilers have to, in 2015, still have to be able to compile 1962 Fortran code. Now that is the death caused by backward compatibility. You're not allowed to move on. And those codes you're not allowed to change break because other people do progress. Software doesn't exist in isolation, it exists in the world, and there are other things going on. The latest one's going to be HTML1, HTML2. There's another backward compatibility thing. There's going to be a problem. So hopefully I've encouraged the idea that backward compatibility in Java, or progress in Java, is mutually incompatible in itself, and that we need to have breaking changes, and we need to move on. So, moving on. I want to reinforce this separation of Java, JVM, and the Java platform. And if Java's not going to change, what can we do? Hark back to the question that was answered over there, Scala. See, I moved too far on. I was going to put Haskell in here, Java in here, and say, what was that? And it's Scala. But I already did that bit. Sorry about that. Lost the plot a bit. Back on track. So Scala, how many people actually use Scala? Quite a lot. We've already got the... Yeah. I mean, a number of... We shall not name them, but let's call them banks. Threw out some of their Java code, pulled in lots and lots of Scala code, and are now a bit worried because there's not enough people who actually like Scala to fill the jobs that they've got available. So there's another place to go, Scala. However, can you stand it? I mean, I quite like Scala. I just ignore 40% of it. Many people actually really love it, and that's great. That's fine. I have no problem with that at all. But many people really aren't with it in the Scala sense. And that's the genesis of these two languages. Actually, is that Scala didn't become the successor to Java in that little spot with the question mark. So these are not necessarily the best points for some people. They're the points that come to my mind when writing a slide. So we've got Kotlin. You can intermix Kotlin and Java source codes however you want and just compile it. That is a very nice big win for Kotlin. Ceylon, on the other hand, will interwork with Java, but really they want you to have a Ceylon code base and treat anything of Java as an external library. It works, but it's a different viewpoint of replacing Java. And Kotlin's one is about incremental replacement, whereas Ceylon is a little bit more big bang. Kotlin, influenced by Java, Groovy and Scala, Groovy being the second best language in the universe. Biggie. Okay, I think I was not able to be here this morning, so I didn't hear what happened about the JDK9 and Jigsaw and all that sort of stuff. Hopefully it was good, hopefully it was memorable. What's more memorable is that Ceylon has had modules for ages. The very outset of Ceylon was, we want modules and we want modules now. We don't want to wait. So they didn't wait. They put modules into the language from the start. Whether you like JBoss modules, I don't know, but they're in there. That's what you get. And that's a big plus for Ceylon. For big systems, it's already modular. Kotlin, really nice type system in comparison to Java. And what's the big thing? Null. How many people like null? Yeah, I thought that would be the answer. Occasionally we have to use it to get out of band data from our calls. You have to return null to say fail or something like that if you don't want to raise an exception. Well, Kotlin hits null head on and says most of the types in Kotlin do not allow nullability. If you want nullability, you say it explicitly in the code, in the type system, and it's your problem. So, for example, in Kotlin, there is a string type. You cannot null it. So if you get a value of string type rather, you know it's non-null. If you want to be, I said I was going to be aggressive, partially insane, you say, oh, it might be a nullable string. To be perfectly honest, you really don't want to go here unless you have to. And when you have to is when you're talking with Java code directly. And Java's going to say, oh, here's a string. Oh, it might be nullable, I don't care. In Kotlin, you care a lot. In Ceylon, you also care a lot. This idea of nullable is removed effectively from the language. And that is a huge win, in my view. May not be in yours. But in my view, it's one of the big things about the type system. Ceylon has taken it actually further and has included things like union types. And we'll have a look at those in a few minutes when I show an example. So those are just a couple of, three highlights from each language that really get me excited about those. The other thing that I'm told gets people excited about these sort of languages is that you can target either the JVM or JavaScript. Apparently this helps with end-to-end single language systems, and apparently that's good. From those people's point of view, sadly, I believe in polyglot programming. So I'm not a sort of, I must have the same language end-to-end type person. So I don't know, ashamed to admit I might actually be doing some ES 2016 programming shortly because it's in the browser. Actually, to be honest, I'm going to be using Elm, but that's a completely different topic. But that is an issue up there for Kotlin and Ceylon. You can target the browser if you want. But most importantly, they're languages of the last 6 or 7 years. And they've had all past history to build on. And so they are, as the saying goes, standing on the shoulders of giants. So let's have some code examples for the next 20 minutes. You've got to start with Hello World. It's traditional. You just have to do it. Sorry. So here we have, go on, you've got to guess the language. So what's the one over here? Okay, Java. It's probably Java 4.3 or something. Oh no, that doesn't exist. 4.2? I don't know, something like that. I have no idea. I haven't written Java in like 5 years. Okay, anyone want to guess what this one is? Excellent, it actually shows you're reading the code. I love it. I mean, which programmer reads comments? Okay, so, you know, there's a little pointer over here, top-level functions. Does Java have them? No. Is Java ever going to have them? No. Backward compatibility? Sod off. I want my top-level functions because I think in functions. I don't want to have to build a class simply to have a function. That's the compiler's job. Get these compilers doing their work rather than us, the programmers, doing it. If I want a class, I'll write a class. If I want a function, I should be allowed to do that. If I want global data, I should be allowed to do it. It may come with red klaxon warnings saying, are you being totally stupid? Yes, that's probably a question that needs to be asked when dealing with global data. But are there times when you want it? Sometimes, yes. And if it comes with a final in front of it, that might be allowable because it's immutable. You'll notice that Ceylon have taken a sort of more Ruby-esque view of documentation and stepped away from documentation comments. So they're actually, if you like, annotations, function calls, they're annotating the top-level function. That's cool. But Hello World's only got so much going for it. We could spend another 10 minutes on it. There's a good 10 minutes worth of stuff there. But let us move on just by summarising that point about the compilers and summarising the point that it's all about what I want as a programmer and tools I want to put into my program. So another one we have to do, flick a coin. Is it Fibonacci? Is it factorial? So it's factorial. And at this point, we cease with the slides, so you'll be glad. Well, not cease, we'll come back to them, but you know, death by PowerPoint slide is not going to happen, mostly because I don't use PowerPoint. That joke didn't work, never mind. Right, so I changed glasses at this point from the nice rose-coloured ones, which try and stop me getting migraines from these lights, to these, so that I can actually see what's on the screen. Is the font size big enough at the back? Yeah. Cool. So let's do some factorial in Ceylon first, before we actually look at the code itself. Oh, I've already compiled it. That was a bad idea. But it does leave us with the source. So we don't have the standard Maven rules about you must have a s followed by a main or a test and a whatever. Slightly different rules. The Ceylon compiler wants the source in source, and then, as we see here, UK org winder, because I happen to own uk.org.winder, so if anybody else uses that as a package path, I can I sue them? No, I can certainly go and smack them about the head with a wet fish or something like that. The important thing is here that you don't actually need package statements in your code. Now, Java 1.0, why did they demand that you have your source in a particular path and then a package statement as well? Saying the same thing twice? What happened to do not repeat yourself? Well, that's a bit unfair, because you could have put all your source in the same directory. The source wasn't structured in Java 1. It still isn't in Java 8. You know, backward compatibility and all that sort of stuff. So the Ceylon folks said, well, if we're going to structure our source code as well as the compiled code, well, that defines the package. That's cool. So we actually don't need this file, which defines... Well, actually, we don't need that one. We do actually need that one. I'll show why in a moment. Here, the definition of the module. So your module structure is in the source code. It's not in the build system. Hopefully nobody's using Ant. No, a few of you are probably still using Maven, even though it's sort of 1990s technology. Some of you are probably using Gradle, which is probably the right thing to do. I told you I was going to be opinionated. Mostly because I still think there's one line of mine in the Gradle source, but never mind. We want to go and have a look at this source. No, we don't know the source. That's the one. We get down to there and get down to there. And we can have a look at this. So more of the package. And so it's not dry. It's still having to state the package name, but this is the interesting bit, the shared. By default, packages are not shared. In other words, they're only within the module. So the shared says, oh, this package, it is viewable outside the module. Modules directly built into the language from the start. What about the module? Okay, so we are targeting the JVM with this module. We are calling it UK org winder maths, and of course 0.0.0 because it's the first item. It's okay. No, most people call it 0.0.1, don't they? When you do the first one, which is bad counting because that's the second one. I would love to use Java 9, but there are still some issues with Ceylon, Gradle, Kotlin with Java 9. But I'm importing Ceylon.math. So Ceylon.math is a module. Where is it? It's in the herd. So Maven has Maven. Well, actually, I suppose Maven has Maven. Gradle also has Maven, but Gradle usually goes to JCenter. Yeah, because JCenter is just that much faster than Maven, I am told. But anyway, Ceylon has herd. So when you say compile my module, we'll have a look at the code in a minute, it looks at the module specification. This module depends on Ceylon math. Go and get Ceylon math from the herd, compile it and put it in the place. So very like Maven and Ceylon, Maven and Gradle. So what about the actual code itself? I think we called it factorial, didn't we? Because it's, no, we called it factorial for some stupid reason. Okay, so there, do you know that's a little bit too yellow? I think we deserve some colouring. So we are going to use the one true editor, which is? Emacs. Oh, it's got to be Emacs. Oops, sorry, Soundman. I bashed the volume. Okay, so proper Emacs. Try doing that in Vim. Okay, so we're importing Ceylon Math whole. That's not the whole of Ceylon Math. That's Ceylon Math whole, the package, from which we get whole number 012. Yes, big integer. If any one of you thought we were going to do factorial with integers or longs, wrong. We want to be able to calculate factorial of 1,000. And I bet if you try doing that with integers and longs, you've probably wrapped round overflow about 20,000 times. So proper integers here, ones you would use in finance or proper maths, where you're involved in big numbers. I forgot my mouse, rats. Never mind. Can only wait so long. Look here. An example of this union types. This function can take a type which is an integer or a whole. Why do we need overloading when we've got a proper type system? Well, that's actually could be argued. We could go to the bar and discuss that for about 4 or 5 hours. It is that deep an issue. I hate overloading when I've got union types. So I just fell for Ceylon as soon as I saw this. The type system just works for me. It may not work for you, personal differences. Obviously, if you've got union types, you've got to be able to distinguish them. And so we have a way of saying, you know, am I the whole number? Am I the integer number? And why is that? Because at times, you can't, panic. If you're going to do that or that, you know, the operator's only overloaded a bit. You can't, in this particular language, say, is an integer less than a whole? You've got to say integer less than integer or whole less than the whole. I could have done it a different way, but for this example, I wanted to show the switch statement. And so it's been a little bit of an artifice. No. Okay, what else we've got? That's just validate. Let's get down to an iterative thing. When you get most people saying, do me an iterative version, you get for loops. No, we don't like for loops. We don't like them a lot, unless we absolutely have to, and you don't need them here. Why not? Because you can reduce things. Okay, so I'm not going to go too deeply into why this is bad and this is good. If you want more on that, we'll have 2 hours hands-on tomorrow discussing the word declarative. And the discussion about those two really depends on the word declarative. Have I done a good enough sales job for tomorrow at 11:15? Okay. Variable. Ceylon doesn't like variables, so you have to say variable. If you don't say variable, it's a binding, one-to-one binding, immutable forevermore. So if I just said whole total equals 1, like big integer, 1 equals whatever, in Java, you'd have been able to change it. You'd have to go final. Now, despite me banging on about it for 10 years, most programmers using Java still don't use final anywhere near enough. So, Ceylon has certainly said normal variables effectively are final binding, because that's the right thing to do in a language which is worrying ongoing about concurrency and parallelism. And very few Java programmers don't do concurrency and parallelism. We could go on a little bit further down here and have a look at the, whoops, wrong way, the two recursive things. Anybody who thinks this one is a good idea, okay, the kind word is naive. The other word is first-year undergraduate. Anybody seen doing this out there claiming to be a professional programmer should contemplate resigning and taking up a new position in a completely different field. Why? Because this is not tail recursion. And the only sane way of doing recursion is tail recursion, and that's why we got this thing. But it's still not cool because JVM doesn't really do tail recursion. So recursion, just a generally bad idea. Scala's got a tail rec to try and get round it. Kotlin has got a way of trying to get round it. Groovy's got a way of trying to get around it. Don't bother. What you want to do is, is to go there. Higher order functions, implicit iteration, immutable data. Okay, that was factorial. There's 3 or 4 more hours of stuff we could do on that. This is just a glimpse at the programming language to give you an idea of the code in a trivial example that the example itself, the algorithm itself, doesn't need thinking about. We were just looking at the code. So I'm going to switch, not editors. I'm just going to switch from there to, I can use minus, can't I? Yes. After so many years, I still can't cope with bash. Right, Kotlin. Kotlin, very much a Gradle-oriented language, or IntelliJ. I'm not going to get into the JetBrains sales thing. And in fact, the JetBrains folk wouldn't either. Kotlin is a language separate from IntelliJ. It's just that the IntelliJ people have really good support for Kotlin. Why? Because IntelliJ is being rewritten in Kotlin bit by bit. And that's one of the big things for Kotlin. Notice it's build.gradle.kts, none of this groovy stuff. The build script is Kotlin. So we can have a look at that. So here are Kotlin as a build script, replacing Groovy. What's the difference? Kotlin is compile time type checked. So this script, as you write it, it will be compile time type checked in an IDE that supports that sort of thing. And I don't know about Eclipse, I haven't used it in Yonks, but certainly JetBrains IDEA does a very good job of that. As you can see, I've got a whole load of good stuff in there, like test frameworks. If we had longer, we could discuss test frameworks. Ceylon has a very good one. Kotlin has a very good one, Kotlin Test. And they both support the one true way of testing this stuff, which is property-based testing. Now again, there's hours and hours of stuff, so that's a throwaway signpost. Property-based testing, really important for these sorts of codes. But you want to see a little bit more than that. And so we've got a tree again, and so back to the dreaded Maven structuring, the separation of main and test and Kotlin and all that sort of stuff. But we live with it because it sort of works. So let's use Emacs because it's obviously the one true editor. So we can go down to maths here and we'll have a look at factorial. Simply because. No, that was the wrong thing to do. That was a better thing to do. Is that font okay? Cool. So yes, we do have package statement, not very dry, very consistent with Java. So again, highlighting that Kotlin has stayed closer to Java. Ceylon has done things a little bit more pure from the outset. We're pulling in just straightforward Java things, showing that although Kotlin has a nice type system, it's doing things very harmoniously with Java. Oh, look, big integer 0. Yeah, we know about that. Big integer 1. Ooh, 2.bigint. Oh, we like that. If we got a chance, we'll go and have a look at that code. There's the validate here, because everything's being swapped into big ints. So rather than work with whole or integer, as I did in Ceylon, here I'm going to enforce some overloading so that we can deal with big integers, integers and longs for each of the algorithms. Okay, that's just the way it's done in this particular way, code base. And there's the for loop for I in range in a range. So I don't know where they got this from Python or somewhere else. I sort of think I write Python, it just turns out to be Kotlin, sort of. Notice total times equals I, big integer. Try doing that in Java. Yeah. And we can say, you know, here we're saying, here's a complete function. It's a single expression. And that's, again, the pull. Ceylon has it in some places. Didn't have an example of it in that code. But Ceylon has also picked up on this idea. And Scala championed it, really. So they were the first one in the game, 2004-ish. Instead of always having to have a open curly, close curly block, you can have a single expression. So here's a pull from the functional languages where everything is an expression. Immutable values, create a value by evaluating expression, move it on. And so we're seeing that in these two locations. The overloads are defined as evaluation of a single expression which calls the big integer version. Yeah, that seems really nice. Like it. So that's the recursive one. We can move down fold. I didn't show the fold one in the Ceylon. I showed reduce. Reduce, fold, all very much the same idea. It's internal iteration. It's about being declarative. It's about saying, I've got a start point. I've got the fold I want to do and the initial condition, and I've got the closure, or the lambda expression, that has to be evaluated at each time around the loop. And it's basically a totalization. So T is the totalizer, and I is the instance for each time around the loop. Yes, sir?
Why do I need both an int and a long overload?
Sorry, the question there was, why do I need the int and the long overload? Is because if you have a strong type checking and you say 0, So if I was to say fold ive of 0, 0 is going to be an int or a long. It won't convert up to a big integer.
Yes, sure. But why int and long and big integer? Why all
Well, this is the one we need,
yeah.
and you don't get any built-in. If I only had a long and gave it fold eve of 0, it would say type error, because there's no automatic conversion from integer to long with the literals. You have to say 0L. I think we can dispense with threats about the recursive stuff. Hopefully you've gone away with that as a measure. How about something... 10 minutes. Yeah, okay, so we've got a choice. Let's throw it open to the audience. A quick look at some real stuff, for some definition of real. Anagrams program, word count program. Those in favour of anagrams? A few. Those in favour of word count? Less. Anagrams it is then. So we'll have a quick look at anagrams. As you can see, I've done it in a few languages. Not many. Ceylon or Kotlin? Those in favour of Ceylon? 2 or 3. Those in favour of Kotlin? Bloody hell. Sorry guys, I did try to get some Ceylon there.
Can you ask again?
Pardon?
Can you ask again?
No, I think this is like the Brexit vote. We've got the will of the people. So Kotlin it is. Oh, rats, clean. No, we're not allowed to have... No, there we are. No detritus allowed. So we've got in here an anagrams program and some testing tools. If I've got a chance, we can open up the testing. I'm going to ship all of these codes onto GitHub Saturday morning. So everything will be available on GitHub, all of those languages. I just want to keep them slightly secret until after tomorrow. So anagrams. So let's have a look at the actual source code. Again, it's summary. I'm not going into massive detail. But these codes will be available. You can go and have a look at them some more. So what's the most important thing about dealing with anagrams is that you've got some main function. And notice the word fun. I hadn't stressed that before. So with Kotlin, you always have fun. You do not have an option. And here is following the Scala Pascal. I think people noticed that before. Types following a colon after the name of the variable. And vals. I'm sorry, val, var, Scala, Kotlin, you got it wrong. There's just not enough cognitive difference between val and var. The variable thing in Ceylon, so much better. But anyway, val and var it is. Val, a binding, immutable, can't change it. Var, variable, you can change it. It's good that we have these things explicitly. No type specification, but strong type checking at compile time. So there's masses of type inference going on here. So we can guarantee that dictionary is a mutable set of string because we said so. If you've initialized it, that's it. You know the type. Some if statements, else's. Yeah, we're just selecting between whether we're choosing a file or doing some args map file it, a whole load, a sequence of files from the command line, or just one. But then you get this chained thing. You know, and Java 8 finally got that stuff with streams. A little. Didn't go far enough. Kotlin, Ceylon, Scala were already there, already had it done properly. But notice here we've got a dot filter, so if doing the standard filtering out, just give me the files, and then for each of those files do something. So it's that fluent way of working is very much core to Kotlin and Ceylon and Scala and streams processing in Java. We've still got whiles and all that, so that's all fairly normal type stuff. Let me just say find the anagrams of some word in some dictionary and then print them all out. So the hard work is being done in the... I'm not sure what's going on here. Right, okay, let's actually do it the hard way. So those were the fun permutations. Never mind. And we're doing it with a word and we're delivering a set of strings. And so, if we got some ifs and elses, but in the end you've got a couple of for loops. Permutations is an n-squared thing. You can get outs, but it is fundamentally an n-squared thing. So you're going to be having two for loops, one way or another. And I've chosen to express it as for loops because for me that was the natural way of doing it. You could have done it with for each, but I chose this way. But that gives you an idea of, these are the functions that come out of it. Find anagrams. Oh, why didn't I do that as a single equals evaluation of expression? I don't know. I'm going to go and hit myself over the head with a fish a few times after this session. And then you get the dictionary of paths and things like that. Reading a line. I/O in Java. Why? All those catches and finallys and, for goodness sake, it's a failed experiment. Give up on it. Checked exceptions. Out. Go. Not wanted. So anyway, we read a line. I'm just being a bit blasé here, not worrying about the exceptions. Because I don't actually care. Ooh, no new keyword. Just a trivial little thing, but coming from my Python background, love it. Why bother with new? It just gets in the way. The name of the type specifies you're going to construct an instance of the type. Why bother with a new keyword? Very, very 1960s. Which fits with the music we were hearing earlier. Oh well. So just quickly, I've got about a minute just to show you a few tests. So if we go to the source test and do the anagrams. Okay, so here we have a nice way of testing these anagrams. So Kotlin test, and you sort of, for all, generate set of word-like strings. Okay, so the function somewhere that gives me an iterable over word-like strings, 10 of them of length 10. And for all of those, make sure that this expression is true. Now, this is the one-off example we'll see of effectively property-based random data generation. If you're not doing this form of testing, you should. There are actually ways of doing it in Java. I will leave you to find that out. I will tell you that it's way, way easier in Kotlin. It's also way easier in Ceylon, but it's way, way easier in Kotlin. Here we are. String spec from Kotlin test. Huge win. Throw away all your Java tests, do everything in Kotlin. You can test Java codes with Kotlin just like you can test Java codes with Java. Where's the loss? However, my time is coming to a close, so I must bring this to a session because you're all thirsty and there's beverages outside, and I'm absolutely certain that you are thirsty. I know I am. I may even well have a beer. Okay, so a big hate C++, Python have got operator overloading. It's good. In the 1990s, the progenitors of Java decided that you, the programmer, were incapable of dealing with operator overloading. That I find complete absurd arrogance. So they took it out of the language, and every other JVM language since has put it back. I think this tells us something. Language evolution by language evolution is hard because of backward compatibility and the people who insist upon it. So let's do the get round it and say, let's just replace it. So let's go for a new language instead of using an old language. And the JVM is a beautiful place to do this. And Ceylon and Kotlin are two of the examples that do that. There are some headlines here. I'm sorry, I've got a flashing red light here, so I'm just about to be yanked off stage. I'll put the slides up, so if you need these, you can get them. Yeah. I mean, Java 8 on Android, maybe in 10 years' time. I don't need to say anything to that one. I bet nobody's going to do it. You're just going to use Kotlin. And I believe that that is the case for Kotlin and for Ceylon. Thank you very much.